Okay, it is Tuesday night's homework that we are reviewing. It says, Eric went to a festival with 50 tickets and rode the Ferris wheel 12 times. Every time he rode the Ferris wheel, he had to use 4 tickets. How many tickets does he have when he leaves the festival? Well, the first thing I know is that this is going to have more than one step. Now I'm going to go back in and try to underline all the important information. I know that he started with 50 tickets and he rode the Ferris wheel 12 times. It tells me here that every time he rode the Ferris wheel, he had to use 4 tickets. So the first thing I'm going to do is figure out how many tickets he used on the Ferris wheel. So I know that he rode it 12 times, and each time he had to use 4 tickets. So if you want to think of that, you're going to have 4, and you have that group of 4 12 times. So I'm going to multiply this because it says every time he rode it, he had to give 4 tickets. 4 times 2 is 8. 4 times 1 is 4. So he used 48 tickets. He started with 50. So if he began with 50 tickets and he used 48 tickets, he no longer has them. So when I'm thinking of an operation about like giving away or not having any more or taking away, I'm going to subtract. And 48 from 50 will give me 2 tickets left. The next question asks me what is the prime factorization of 72? And the easiest way to get prime factorization is to use a prime factorization tree. So you need to think, what do you multiply together to get 72? And I know, if you look at your multiplication grid, or if you know your multiplication facts, that 8 times 9 equals 72. Now in prime factorization, I want to reduce my number to only prime factors. So 8 is not a prime number, so I'm going to have to reduce that. 8 is 2 times 4. So I know that 2 is a prime number, so I can leave that alone. But 4 is still not a prime number. So what factors make 4? 2 times 2. I circle them so that I know that I'm done with that part of the tree. Now I'm going to look at 9. 9 is also not a prime number yet. So what 2 numbers can I multiply together to get 9? And I come up with 3 times 3. And I know that 3 is a prime number. So the prime factorization of 72 is 2 times 2 times 2 times 3 times 3. Now, if I wanted to do it in scientific notation, I would say that the prime factorization of 72 is 2 cubed times 3 squared. This one says circle the statement that is true. It says 1, the sum of an even number and an even number is an odd number. So we've been practicing these in class. You need to create your own number sentence to check. So sum, I know that means addition. I need an even number and an even number. So the smallest even number I know is 2. So 2 plus 2 equals 4. And this one says that the number is an odd number, and I can see right here that this is an even number, so 1 is wrong. The second one says the product of an even number and an odd number is even. So this has the word product. I know that means multiplication, and I have an even and an odd number. So again, the lowest even number I know is 2. The smallest odd number I know is 3. 2 times 3 is 6. Is that an even number? It is. So I'm going to circle it. The last one says solve. Now, I have been solving them in US Standard Algorithm, and I'm going to continue to do that with this one. It says 5 times 3 is 15. I'm bringing that 10 over into the tens place. 5 times 9 is 45, plus 1 is 46. 5 times 4 is 20, plus 4 is 24. I'm going to mark out that 5. I'm going to bring down the 0 because he's going to hold my place, 0 the hero. I'm going to multiply by 1. 1 times 3 is 3. 1 times 9 is 9. 1 times 4 is 4. And then my last step is adding. 5 plus 0 is 5. 6 plus 3 is 9. 4 plus 9 is 13. 4 plus 2 is 6, plus 1 is 7. Now, if you did solve this using partial products, again, that is fine.